Hello everyone, welcome to Pep Coding. I hope you all are doing good. Today we are going to see about the topic of packet format, how the packets are formed. In previous video, we discussed about what is packet. In this video, we are going to see about the packet format. Without any delay, we can move on to the topic. Okay, in this video, we are going to see about an packet format. In the previous video itself, we saw what is a packet. In this video, I'm going to explain about the packet format, right? In that, the first one will be, this is our packet format, okay? In the packet format, the first field will be the general header, then the other field will be the chunks. We have n number of chunks. I'm going to explain those chunks one by one, okay? Fine. This will be my general header. Okay. We are splitting our packets into two types, right? One is an header, another one is chunks, right? The first one is an header. In header, we have the source port address, destination port address, verification tag, then checksum by 32 bits, right? We are sending the particular chunks from the sender to the receiver, then the corresponding receiver should receive that detail, right? If there is one sender sending two different information like hi, good, okay, to the different fields, right? Then this hi should have this destination address, then this good should have this destination address. Then only we can give our informations to the respective receivers, right? So that we are using the source port, then the destination port address. Next one is like verification tag. We already explained about the TSN, right? The verification tags is fully depends on that. If we are sending a particular information, then we should have the verification tag. Then only there is no intermediary problems with the fragmentations. That is, we are splitting up our information into the fragmentation, that is chunks. In the each chunks, we have an SSN number. There is no collaboration between that, right? It should be carried out by that things. That is about the verification tag. Then what is checksum? In SCTP, the checksum must have like 32 bits, right? It is 32 bits, while in the TCP or UDP, it is only like 16 bits. Okay, we are using checksum for whether the corresponding receiver is receiving the corresponding frequent of the message, right? For checking those things, we are using checksum. It is about the general header. Then we can move on to the chunks. In chunks, we have the type, flag, then length, right? We are going to see about the flag, those are chunks, right? We are going to see about this in the upcoming topics, okay? Then type is like whether it is occupying 0 to 7 bytes, whether we are sending a what type of messages. It will be an audio or video or text or anything, right? It depends on the type. The flag and length are depends on the type. The difference is the type is like 16 bit, the flag is also in 16 bit, but the length is carrying 32 bits. 32 bits. In the flag, we have 246 bits, okay, but in those, some of them only are defined. Okay, remaining that are not defined, that will be used in the future usage, right? Then we have the chunk information. It carries the multiple of 4 bytes. That is, if I'm sending one message, okay, if it is having like 2 bytes of messages, okay, then 2 into 4, it should receive as an 8-byte message. Okay, we are while we are splitting out our information into the chunks, each chunk should be multiplied by the 4. While the receiver receives those informations, they should have the multiple of 4 informations. Otherwise, some of the informations are we missed in somewhere. Okay, this is the one important advantage of SCTP. Like if I'm receiving 17, okay, then 17 is not the multiple of 4, right? After that, there will be a 20 that is a multiple of 4. Then 18, 19, 20. That are the 3 bytes of messages that particular chunk missed somewhere while while in the traveling. We can find this with the help of checksum information, so that we are multiplying into 4. If I am getting 16 bytes in the receiver end, then there is no problem. That is correct. We have an exactly what the sender sent. We are got that informations. Okay, for because of these purposes, we are using this checksum informations, right? Okay. In chunks, we have the types of chunks. The one is data, init acknowledgement, SAC, that is selection acknowledgement. There are 0 to 10, right? 11, 12, 13. 13 chunks. I'm going to explain those 13 chunks in this. I will give a brief introduction about all those things. You can understand those easily. In the data, we have the data chunks in the flag, that is then 8 to 16, that is 15. In those, the 5 part is reserved, remaining 3 will be 1. U is defining as for unordered. Okay, B is, we are using the B for bindings, sorry, beginning. Okay, B we are using for beginning, E is using for ending. Okay, if that is unordered, the value of the one we are going to given, that is the particular fragment is unordered fragments, right? Then in the beginning and ending, if we are giving in the beginning and ending, if we are giving 1 0, it should be the first fragment of those particular data, right? Then if it is 0 0, it will be an middle fragment of this particular data. If we are giving 0 1, it will be an end fragment of particular data. This is carrying the whole data chunk. Okay, beginning will be the 1, ending will be the 0. It is then first data, then 0 and 1 will be the last data, 0 and 0 will be the middle data. I hope you understood that, right? Then the transmission sequence number, stream identifier, SSN. This all those things we are already seen in the previous video, right? Protocol identifier also. User data is nothing but what are the informations that the sender is going to send to the receiver. That is comes under the user data. Then we can move on to the, okay, next one will be the, okay, sorry. Okay, next one will be the init chunk. Okay, in the init chunk, we have type, flag, length. Then initiation tag, advertised receiver window credit, outbound streams, maximum inbound streams, initial TSN. I will explain those things, right? Initiation tag is that when we are starting, I told you that 1 0 will be the starting point of fragment, right? While we having this, we are going to do our operations, right? Then it will be an initiation tag. When the fragments that should be start their traveling phases from the sender, right? Advertised receiver window credit. That is, what are the messages that are going to show us then in the receiver window? Okay, it should be as advertised receiver window credit. Then the outbound streams. Outbound streamers, this is the sender, right? While sender is sending something, what are, okay, what are the output that is coming out from the sender's field? Okay, that is output streams, that is outbound streams. Okay, then what are the inputs that is going inside the receiver's field? That is about inbound stream. Okay, it should be like outbound stream, it should be like what is the minimum field we are going to send. Then inbound stream, it is like what is the maximum amount we are going to send. Okay, initial TSN, we know that TSN is in transition sequence number. The TSN, while the TSN starts, then we are going to start our fragmentations, right? It is all about the initial TSN. This is carried out by the init chunk. After one is init acknowledgement. If those all the things are right, that is the receiver is ready to, we already checked the outbound stream, then inbound stream, then the TSN, we already gave the fragmentation numbers to those particular data chunks. Then we can initiate the translation. Then the init acknowledgement chunk will come. Then it will start their work. It is about Okay, this is about an init chunk acknowledgement. Initiation tag advertised, same we are having. Then we are having the parameter type 7. The type 7 is not only for the init acknowledgement. We are using most of the acknowledgement segments that are carried out by, most of the acknowledgement chunks that are carried out by the init acknowledgement. In TCP only we are having segments. In SCTP we have the term as like chunks. Okay, so we should use the numbering as chunk, right? Okay, then the next one will be okay. Okay, that is type 10. Okay, it is carried out with the type 10, then flag 0 length start cookies. We are going to start cookies, that if there is an any duplicate values, or if there is any repeated values, those things, then if we have any problems while transferring our information from the sender to the receiver, it will be carried out by the cookie echo. If cookie echo is coming, then it will be confirmed by then cookie acknowledgement chunk. Then we need to take the steps for those things. Okay, this is cookie acknowledgement. It is carried out by then type 11. Okay, next one will be the SAC. SAC is selection acknowledgement. It is nothing but what are all the acknowledgement we are getting. The selection acknowledgement is going to process that. Then it will going to do the particular value according to that. For example, cumulative TSN acknowledgement. That is initiation tag we are giving TSN, right? The TSN value is given. So it is like, okay, we need to start the process, right? Then the advertised receiver window credit is given. Then we need to show the particular information to the receiver. Then the number of gaps acknowledged. If some statements there is a gap, if that gap starts, then we need to give those number of gap acknowledgement. Number of duplicates. If we are getting the repeated informations again and again, then if we are giving an acknowledgement of the duplicate, then it will work. Selection acknowledgement is commonly for invoke the acknowledgement statements. That's it, right? Next one will be the heartbeat and heartbeat acknowledgement. We are using this heartbeat acknowledgement like just we need to check the liveness of the particular fragment or the particular chunk. If we are sending particular data chunks, whether this data chunk is alive or not. For that, we are using the heartbeat. Okay, while we are sending the heartbeat, if it is working, if it is alive, then it will tell us like yes, I am alive. Okay, if we are receiving that, then we are sending the heartbeat acknowledgement. If the heartbeat acknowledgement is received, then the process will continue. If we are checking the heartbeat acknowledgement, there is no liveness in this particular data, then we are not receiving the heartbeat acknowledgement. If those okay, that particular data is blocked somewhere, we need to retrieve the data, or we need to get the data again from the sender. Then only the receiver can receive those messages. These works are carried out by the heartbeat and heartbeat acknowledgement, right? Then we are having the shutdown acknowledgement, and the shutdown complete, right? If cumulative TSN acknowledgement is coming, then okay, that is the TSN, it reaches the last end point, then we are getting that acknowledgement, it starts shutdown. Okay, the process is completed, we need to shut down. Then shutdown acknowledgement. If shutdown acknowledgement is received, then we can shut down those process. It will be carried out by the 15th chunk. Okay. Then the last, okay, not last one, the next will be an error. Okay, in the error, if we are causing one or more, okay, type, we are having the type, some of the is a type 9, it should be carried out by an error. If we are getting the error, we need to know one thing, that if we are getting the error, our process will not end. Okay, just it is an error, we need to find some other way, or we need to find some other source. Okay, there is a difference between error and abort, right? If we are receiving more than one error, or we are getting simultaneous error, for example, in the phone, while we are doing, while we are trying to open our lock, we do it for once wrong, it is not going to abort our process. We can try it again. Okay, after particular time, it will show no, you can't open this, you can't try this again, right? That is an abortion, the abort, right? So after the n number of error causes, then only it will go into an abort phase. Okay. The sum of the error codes like invalid stream identifier, missing mandatory parameter, state cookie error, out of resource, unsolvable address. Okay, these are some of the errors. Abort is like while we are getting one or more errors, then it should adopt the process. No, we are getting again and again, we are getting an error, so it will not going to work out. We are going to end our process. Okay, this is about an abort. Forward TSN. Forward TSN is nothing but one complete process is completed, right? We are from the starting TSN to the ending TSN, we are completed through the completion, or there is a three process. Once we completed all those works, then we are shut down with the help of shutdown complete, right? If we are getting any error, it will going to show an error. We are going to recreate those things, right? Then if we are getting more than error, we are going to abort those procedure. Then we need to move on to the next work that is carried out by the forward TSN. This is all about chunks. Okay, this is all about chunks. We cover all these topics. I hope you are clear in this, right? That is, in the packet format, we are having the header and then chunks. In chunks, there are the n number of chunks. We saw about those chunks and then general header. We completed the packet format, right? Then the next one will be then an SCTP association. I will explain this topic in the next video. I hope you all are understand about the packet format, right? Thank you for watching. Have a nice day.